This video, we're going to evaluate some expressions. An expression is something that is an algebraic statement but doesn't have an equal sign in it. So it's just like a phrase in English that it is not a complete sentence or a complete thought. It's just one part of the sentence. So it doesn't mean anything necessarily all by itself, but that's 5x, which is 5 times a number. And we're going to let x be equal to 4 with what we call a let statement. So we're going to replace x with 4, and we're going to simplify, and that gives us a value of 20. So evaluate means find the value of. So we're finding the value of the expression given that you're told a replacement value for the variable here. I forgot to tell you these are like problems from 8.2, numbers 49, 51, 53, 55, 57, 59, 61, 63, and 65. Okay, so let's go ahead and see the next problem here is going to be z over 4x. So we've got two variables, so we're going to let x equal 5 and z equal to 4. This is going to be 4 over 4 times 5. This is 4 times 1, and the 4's will cancel, and I'll be left with 1/5. Now we're going to evaluate the expression 6x minus 3 when x is equal to 3. 6 times 3 minus 3 is 18 minus 3 is 15. Now we've got the absolute value of 2x plus 5y. We're going to let x equal 4, y equal to 5. So 2 times 4 plus 5 times 5. Inside of absolute value bars is the absolute value of 8 plus 25 is the absolute value of 33, which is 33. Go along here, we're getting a little bit more complicated. So we're going to throw in 3 variables now. This is going to be x times y plus z, with x equal to 4, y equal to 5, and z equal to 8. So 4 times 5 plus 8. I usually make my substitutions in parentheses so that I don't miss any multiplication there. Multiplication before addition, 20 plus 8 is 28. Now we have 9 times y squared. There's an visible multiplication symbol there, but I'm going to put there y is equal to 3. This can be 9 times 3 squared. Exponents before multiplication. 9 times 9 is 81. Now we have x divided by z plus 2y. X equals 15, y equals 3, z equals 5. 15 divided by 5 plus 2 times 3. So division first is 3 plus 2 times 3 is 3 plus 6 is 9. That division only happened first because it was to the left of the multiplication. So was that one. Now we have x squared minus 2y plus x. We have x is equal to 20, and y is equal to 14. So 20 squared minus 2 times 14 plus 20. Exponents first, this is going to be 400 minus 2 times 14 plus 20. Now multiplication before addition and subtraction. Addition and subtraction can happen in any order that I want. Sorry. So I'm going to add these two together and get 400 plus a negative 8, which is the same as 400 minus 8, which is 392. It was just easier to add the negative 28 and the 20 in my head because they were closer together than to try and take 28 away from 400. So there you go. Got one more problem here in this set, looks like. And it's x squared plus z over y squared plus 3z. And we've got substitution values of x equals 3, y equals 15, and z equals 219. You don't have to do this, but you'll notice I'm putting a line through my z's so that they don't look like my 2's, because my 2's and my z's look very similar. So that's the only reason that I'm doing that. 3 squared plus 19 over 15 squared plus 3 times 19. We're going to have to simplify numerator and denominator separately before we can take care of the division. 3 squared is 9. 15 squared is 225. Nine plus 19 is 28. This is 225 plus 19 times 3. This is 27. So 3 plus 2 is 5. That's 57. This is going to be 28 over 279. 28 is 2 and 14, which is 2 and 7. And so no 2's are in 279. And there's not a 7 in there either, because 279 is 3 times 93, which is 3 times 31. 31 is a prime number, so there's no common factor, so this is simplified. Just wanted to prove that to you. So there it is. And that is our last section of problems for this this assignment. They were calling this assignment number sense. So we'll come back and we'll talk about something new in our next set of videos. See you for them next time.